Good evening, Shekhar sir.
Yeah, good evening, sir.
Good evening, good evening. My slides visible?
Yes.
Yes, sir.
Okay. Thank you, everyone. So today I'm going to discuss the topic parametric tests. So basically, parametric test, assumptions-based tests. Before applying any parametric test, we check assumptions. Is it clear? In case we are not able to fulfill the assumptions of the parametric test, then we will correct our data. So there are three methods of correcting the data: log transformation, square root transformation, and inverse transformation. And then we apply parametric test. Basically, we can divide our research into two parts. One is quantitative research and another qualitative research. Is it clear? So there are two types of research: quantitative and qualitative research. In a quantitative research, we use or apply all statistical tools and techniques such as one sample t-test, independent t-test, pair test, ANOVA, repeated measures, ANOVA, ANCOVA, factorial ANOVA, MANOVA, MANCOVA, and some non-parametric tests such as one sample median test, Wilcox-Conn rank sign test, Kruskal-Wallis test, Mann-Whitney U test, Friedman ANOVA, and some bivariate test like simple regression analysis, chi-square test, and multivariate techniques, multiple regression analysis, discriminant analysis, logistic regression, structural equation modeling, mediation, moderation. So all statistical tools and technique we analyze in a quantitative research. All statistics we use in quantitative research, and we do not use any statistical tool and technique in qualitative research. And we do not test our hypothesis in qualitative research. We test our hypothesis in quantitative research only. Now, question is, why should we study the assumptions of parametric test? Because every test has its own assumptions. So before applying any test, we should check the assumptions of the test. Is it clear? Now, today we are discussing parametric test. Every statistical tool and techniques has its own assumptions. If I want to apply multiple regression analysis, then before applying, I will check assumptions of multiple regression analysis. If I want to apply discriminant analysis, I will check the assumptions of discriminant analysis. So the assumptions of factor analysis different from the assumptions of multiple regression analysis. So today I'm going to discuss parametric tests. So basically parametric test has main four assumptions. The first assumption is the distribution of data should be normal. Means there should be normality in the data. When you check the distribution of the data through graph, the graph should be, histogram should be in a bell shape. Is it clear? It should not skewed either lower tail or upper tail. Then we check the homogeneous in the data set, whether data homogeneous across the two groups or not. Like there are two groups. One is private sector and another is public sector. Okay. So in both the groups, the distribution of the data should be constant across the group. If I'm taking two groups, the variability of the data should be constant. It means the data homogeneous across the groups. The third assumption is data should be either ordinal and continuous data, then we can apply parametric test. We know there are four types of data. We can prepare our questions in a nominal scale, ordinal scale, interval scale, and ratio scale. So this data known as metric data or continuous data, both the data known as non-metric or the categorical, and this is ordinal data. So we can prepare our questions either ordinal and continuous. And the fourth assumption, independent score. The score of one respondent should be unrelated with the other respondents. We should not copy the answer of the one respondent with the other. Is it clear? Now, these two objective in our hand, the two assumptions in our hand, we can prepare our questions continuous scale and as well as independent score. But the two main assumptions, both the assumptions are not in our hand. So the data will tell us whether data normally distributed or not, whether data homogeneous or not. So first of all, we will understand what is normality, what is homogeneity, and how to check homogeneity and normality in our data set. The first is the normality. So we can check normality through graphical display, distribution of skewness and kurtosis, and KS and Shapiro test. KS means Kolmogorov-Smirnov test. So we can check normality through graphical display, value of skewness and kurtosis, and third, normality test. Is it clear? Now the next is we will check the homogeneity of variance, whether data constant across the group or not. So generally, for normality, we use this KS test, and for homogeneity, we use Levin test. In both the cases, the p-value should be greater than 0.05, means non-significant. Although when we test our hypothesis, we desire p-value should be less than 0.05. But only for assumptions purpose, we desire our p-value should be greater than 0.05. Here, the assessing the normality, the first method, that is the graphical display. So in a graphical display, there are two things. One is histogram. Through histogram, we can check whether my data normally distributed or not. Histogram tell us the shape of the distribution. For example, ideally the histogram, there are two variables y and x. Ideally, the distribution of data should be like this: normal curve, bell shape. Bell means ganti. But what happens? We are distributing our questions in a 5-point or a 7-point Likert scale: 1, 2, 3, 4, and 5. So when the respondents fill the questionnaire, they don't fill seriously questionnaire. Generally, they tick either 4, 5, 4, 5 option, or either 1, 2, 1, 2. So when concentration of the data in lower side, means maximum respondent are giving their responses in lower side. They are taking 1, 2, 3, 4, 5. So the shape of the distribution will be look like this. Shape would be look like this. Is it clear? Hello, beta abhi main class mein.
Yes,
So
sir. Yes.
the shape of the distribution, in a y-axis you can see the frequencies 5, 10, 20, 30, 40. If I have 100 sample size, if 80 people are taking this option and rest of the options, the 20 options, they are uh, giving either 3, 4 or 5, so data will be skewed. So if concentration of the data in lower side, so this situation known as the positive skewness. Positive skewness. We should keep in mind when concentration of the data in left hand side, it is positive, and when the concentration, if maximum people are taking option 4, 5, 4, 5, so there are option 1, 2, 3, 4, 5. Then this data known as the negative negative skewness. Negative skewness. Ideally, we desire our data should be normally distributed. Second is the PP and QQ plot. PP means probability plot. QQ means quantile plot. So through this plot, we can identify whether my data normally distributed or not. So first of all, I uh, uh, check. There are three pictures: 1, 2, and 3. Can anybody tell me the graph number 1? Is it more or less normally distributed or not?
Yes.
Is it normally distributed? Because
Yes,
the
sir.
shape of the distribution. And the second picture, is it normally distributed or not?
Is positively skewed, sir.
Yeah, positively skewed.
Positively
So this
skewed.
data not normally distributed. Is it the third picture? Is it normally distributed or not?
No, it's also positively skewed.
Again, it is positively skewed. So both the picture not desirable for the parametric test. If distribution of data look like this, it means we can apply parametric test. The second is the probability plot. Here you can see this is the principal diagonal. Principal diagonal you can see here. If all the observations lie in a straight line or in the principal diagonal, then the data normally distributed. If distribution of data above the principal diagonal and below the principal diagonal and again above the principal diagonal, data not normally distributed, because data should be in a straight line. But here the data it is the curve shaped data, so not desirable for parametric test. Same as the third picture, you can see the data not normally distributed because the data in a curve shape. Again, this is not desirable. The next method, that is the QQ plot, quantile plot. In a quantile plot, again, you can see the very few observations below the lower tail and a few observations above the upper tail, but more or less data in a straight line. So we can assume this data normally distributed. But the second picture, you can see this again, it is not in a straight line, it is in a curve shape. The third picture, it is not the curve shape. So this is the first criteria. Through graphical, through pictures, we can identify whether my data normally distributed or not. The second criteria, when we analyze the
Excuse me, sir.
descriptive statistics. Yes.
So if I do a survey and then if I get results which are not normal, then is my survey completely wasted, or can I do something to make the data normal?
Yes, 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 sir. I I told you, if your data not normally distributed, then you will correct your data. You can see here. So the yes, if my assumptions do not fulfill the criteria, then it means my data not normally distributed, not homogeneous. It
Yes.
doesn't mean that my data waste of time. We will
Okay.
correct our data, and for correcting the data we have three methods: through
Okay.
log transformation, square root transformation, and inverse root transformation. After this I will uh, discuss the correcting of the data, how to correct our data if data
Okay.
not
Okay.
normally
Okay.
distributed or not. Okay.
Okay.
Excuse me,
Now,
sir. Excuse
yes,
me,
yes,
sir. Just to go back, I am sorry. This p value you mentioned, sir, it should be more than 0.05.
yes, yes, yes.
So I could not understand the significance properly. Can you
Okay,
please
okay.
repeat, sir?
Yeah, yeah, yeah. Thank you, sir. Actually, what happens when there are two things. When we test our hypothesis, we assume the p-value should be less than 0.05 for checking the significant difference. Okay. And for assumptions purpose, we want the data should be non-significant. Non-significant means, for example, this is my population. Is it clear? The population, the pop, and I'm taking sample. Sample means a small part of this population. If characteristics of the population and sample same, it means there is no difference. Is it clear? If the data is homogeneous and my sample also homogeneous, it means there is no difference. The data, and the probability value decide whether data normally distributed or not. Is it clear? So the population mean does not the population mean should be equal to the sample mean. Is it clear?
Okay,
So
sir.
in a p only for assumptions purpose, because we are taking, if this sample mean different from the population mean, it means the data not normally distributed. Whatever sample we are taking, all the characteristics in a sample should be same as in a population. Is it clear? So this is about the p value. Only assumptions purpose we check whether p value less than 0.05 or greater than 0.05. If it is greater than 0.05, it is okay, it is desirable for parametric test. Second method to how they check the uh, skewness and kurtosis, the value should be between the range -1 to +1, value of skewness and kurtosis. So skewness, I told you there are three types of data. It is completely normal. This data positively skewed. This is negatively skewed. And kurtosis tell us the flatness of the data. The You can see here, when sample size is less, the flatness of data. The data would be look like this. So this is platykurtic data. Platykurtic. If we increase the sample size, then data maybe look like this. This is mesokurtic. Mesokurtic. And third is, the if we increase the sample size and data look like this, so it is leptokurtic. Leptokurtic. So who will tell whether my data skewed or kurtosis? So the value of skewness and kurtosis will tell us the data normally distributed or not. So here the p value, sorry, the value of skewness and kurtosis should be between -1 to +1. If value of skewness and kurtosis outside this range or outside this range, the data not normally distributed, and this data not appropriate for parametric test. Ideally, the value of skewness and kurtosis should be 0. The third method generally we use in our research paper or thesis writing, that is value of the case test. The third test, that is for normal distribution, the p value should be the greater than 0.05. If p value greater than 0.05, it means data normally distributed. Second thing, that is the homogeneity of the data, whether data homogeneous or not. So how will we assess the homogeneity? We can check homogeneity through live-in test. Okay. But first of all, we should understand what is homogeneity. Homogeneity we can check through the this live-in test. Here there are two pictures. In the left hand side, you can see homogeneous data, and in the right hand side, heterogeneous data. In a normality, in a homogeneity, the range should be constant across the group. Constant across the group. Here, range is constant across the group. Okay. So if range constant of the group, the data homogeneous. If range different, here range is very less. But in this case, you can see the range range is very high in last case. You can see here this picture. The range is very high, range is very low. What does it mean? I am taking very simple example to explain this concept. So there are two pictures I am creating here. This is homogeneous. Okay, the Y and X. X income, monthly income, and Y expenditure. So I'm taking three groups. The one group, the monthly salary 50,000. Another group, monthly salary 1 lakh. The monthly salary 1,50,000. 1,50,000. Is it clear? And I'm taking 5 observations. 5 people from this 5 families whose monthly income 50,000, 5 families whose monthly income 1 lakh, and 5 families of the 5 families whose monthly income 1,50,000. Is it clear? So the mean X1, this is mean is 30,000. 30,000. What does it mean? The one family member expenditure of 45,000. Second family member 40,000. Third family member 30,000, 28, and 25. So maximum is 45, minimum is 25, and what is the range? Range is 20,000. Is it clear? Another family whose monthly income 1 lakh, the mean expenditure 70,000. Is it clear? So one family expenditure the 85,000, 80,000, 70,000, and 68,000, 65,000. So here 85 and 65. So range constant. When range constant across the group, the data normally, the data homogeneous. There is no issue of heterogeneity. Same as you can take the other example, the mean is 1 lakh rupees monthly expenditure, and 1,15,995. The same data, if I draw the expenditure of 5 families, 5 families, the X1 bar, the 30,000. Is it clear? 30,000 rupees mean. One family 45,000, 40,000, 35, 30, 25. And what is the range? Range is 20,000. Another group, the 70,000. 70,000 mean. And one family expenditure 1 lakh rupees, another 90,000, 80,000, 70,000, 60,000. So here range not constant across the group. So what is the difference here? There is 40,000. So range should be constant for across the group. Then we can say data is homogeneous. If range not constant across the group, it means the data heterogeneous. There is a heterogeneity in the data set. So here there are 2 pictures and there are many categories, 7 categories. So you can see in the left hand side picture, the distribution of data range more or less same across the group. But here the range is very less and here range is very high. So the data not normally distributed. Sorry, data not homogeneous, so data is heterogeneous. So there are this is graphical picture of the heterogeneity, and another method, that is through leave-in test we can check our data whether my data normally distributed or not. So I will take the example. Now the correcting data, if my data not normal, not homogeneous, now question is what should I do? Is any criteria to correct the data? Yes, we have 3 criteria to correct our data. One is by using log transformation, square root transformation, and reciprocal transformation. You can see the first picture, log transformation. The second picture is, you can see here, square root transformation. And third is the reciprocal transformation. So you can see there are 2 pictures, before and after. Before means before reciprocal transformation, the data not normally distributed, it is positive skewed. But after correcting, our data more or less normally distributed. So there are 3 methods. You can see the another method, that is the square root and the log transformation. Now I come to the parametric test. What is parametric test? I told you parametric test basically
Sir,
assumptions based. Yes.
yeah. Out of the 3 tests, is there any criteria where to use which test, square root or log or in reciprocal? Depends on
Yes,
the
yes.
data distribution.
Yes. So if you want to reduce the positive skewness, then you can use the log transformation method, and square root transformation also reduce the positive skewness. ठीक है ना? तो इस तरीके से हम जो है we can use the test कि whether my data positively skewed or not. So we can correct through the either log transformation or square root transformation.
Thank you.
Okay. Now the parametric test. Parametric tests are those that make assumptions about the parameters of the population distribution from which the sample is drawn. This is often assumption that the population data are normally distributed. This is my population. I am taking a small part of sample. So I will check if the characteristics of the sample same as the population, it means there is no difference. If the sample characteristic different, it means there is the significant difference. So how to check it? So there are main 5 tests: one sample t-test, independent t-test, pair test, ANOVA, and repeated measures ANOVA. So one by one I will take. The first of all, one sample t-test. One sample t-test basically univariate technique. There are 3 types of data in a quantitative research: univariate technique, bivariate technique, and multivariate technique. Univariate technique means we are analyzing only one variable. Bivariate means we are analyzing 2 variables, and multivariate means more than 2 variables, means one dependent variable and several independent variable, or many dependent variable and many independent variables, means more than 2. Then we use the multivariate technique. The case study of the one sample t-test you can see here. One sample t-test is used to test whether a population mean is significantly different from the hypothesized mean or not. So what is the criteria for applying the one sample t-test? The first is the data should be continuous. Second, data follow the normal probability distribution. The data should be normally distributed. And third, the sample is simple random sample from its population. We should not be biased to select the observations. It is completely random. Now, example of this, what is your weight? Weight is a continuous variable, ratio scale. So we should prepare our questions in a ratio scale or interval scale. Now you can see the case study of one sample t-test. ABC University indicates that the mean weight obtained by students in a class is 53 kg. Okay, university is claiming the mean weight of the students in a class 53 kg. But a teacher from the same university claims that it was more than 53 kg. So he has to prove. Then teacher collected weight of 10 students randomly out of 100 students. Can we reject teacher's claim at 5% significance level or not? So this is our population. Population mean is 53 kg, and he took observations of 10 students. So we will estimate the mean value of 10 students. We will add all the values and divide the number of observations. So we will get the mean value, and then we will check whether this value is significant from the population or not. So before it, we will frame the hypothesis. When we are testing the data, we should develop our hypothesis. There are 2 types of hypothesis. One is null hypothesis. In a null hypothesis, we always assume the population mean equal to the sample mean. Is it clear? It means if sample mean is 54 kg and population mean 53 kg, only 1 kg difference. So this difference is not significant, more or less same. But alternate hypothesis says population mean does not equal to the sample mean. Is it clear? So how to prove it? So I am opening the data set and performing the one sample t-test. I'm opening the data set. The data set basic. I will take only 1 minute to open the file. So one data set, independent t-test plus paired t-test, then ANOVA, and last the repeated measures ANOVA. Now I am showing you the data set. You can see the data set. One sample t-test. Is it visible? Can you see this data set?
Yes, sir.
Okay, thank you. So data is parametric, metric data, continuous data. So before applying the parametric test, one sample t-test, we should check the normality of the data. We cannot check homogeneity of the data in a one sample t-test. Why? For checking the homogeneity, we require minimum two groups, two categories, male, female, rural, urban, whether the distribution of both the groups same or not. So here we will check only normality of the data. How to check the normality of the data? Go to analyze, descriptive statistics, and explore. Analyze, descriptive statistics, explore. Now transfer the weight of a student, this data, into the dependent list. Is it clear? Weight of the students. Then statistics, nothing to do. By default, descriptive statistics, tick. Descriptive statistics means measures of central tendency, measures of dispersion, and distribution. It means through descriptive, we will obtain the results of mean, median, mode, central tendency. We will obtain the result of the dispersionness, range, interquartile range, variance, standard deviation, and third is distribution. Distribution means skewness and kurtosis. Okay, then continue. After continue, plots. Here you can see the normality plots with the test. So we will tick this option. We will tick this option, normality plots with test. Through this tick, we will get KS test P value. Is it clear? Now continue. After continue, okay. So we will get the output. Is it visible output?
Yes, sir.
Can you see this output? Is it visible?
Yes, sir.
Okay, thank you. Now here the value of the case test, that significance means p value. And what is the p value? P value 0.200, yeah, 20%, which is more than 0.05 or 5%. If case test p value greater than 0.05, it means data normally distributed. The data normally distributed. Is it clear? Now, it is okay. There is no problem of the normality of the data. Now we can apply the one sample t-test. So how to apply one sample t-test? The one sample t-test, they go to analyze, compare means, and one sample t-test. Is it clear? The one sample t-test. So analyze, compare means, and select one sample t-test. Is it clear? Again, I am repeating. Analyze, compare means one sample t-test. Now the weight of the student I am transferring into the test variable box. Now what should I write here? Test value. Can anybody tell me through chat box, or you can unmute? What is the test value? Which value I am comparing?
0.20.
No.
Sir, 53.
53. Yes, Prakhar, you are right. 53. We are comparing sample mean with the test value. That is population mean. 53. Yes. And then okay. Is it clear? So after okay, we will get the output, and this is our output. You can see the results of one sample t-test. Here, the mean value of 10 observations, 10 students weight 56.90. So I told you there are two hypotheses. In a null hypothesis, we assume population mean equal to the sample mean. Is it clear? So what is the population mean? 53 kg, and the sample mean 56.9. Whether this difference, how much difference? 3.9 kg. The difference, that is 3.9 kg. 3.9 kg. Whether this difference significant or not, who will tell us? P value. If P value less than 0.05, this means there is a significant difference. But if P value greater than 0.05, we will interpret, no, this is not a significant difference. It is by chance the teacher selected those students whose weight slightly more than the population mean. So here the test value is one sample t-test results 1.414 and p value significant two-tailed. Here p value greater than 0.05. Greater than 0.05 means the not significant. Not significant. Here null hypothesis, population mean equal to sample mean. And alternate hypothesis, population mean does not equal to the sample mean. So here our null hypothesis accept and alternate hypothesis reject. So how will we interpret it? How will we report the results of one sample t-test in research paper or thesis? You can see here. I am opening the slides. The PPT, yes. You can see from the output, since p value greater than 0.05, we do not reject the null hypothesis. It means we are accepting it. That sample mean is equal to population mean. and conclude that the sample mean of a student is not significant different from the population mean. Yes, it means teacher claim was wrong. But if sample mean 70 kg, then when we compare the population mean, it means there is a 17 kg difference. It is a big difference. Is it clear? If I test one sample and the population mean 53 and sample mean is 70 kg, then my p value would be less than 0.05, because this is not a small difference. 3.9 kg not a big difference. So in a hypothesis testing, when we compare sample mean with population mean, or one sample mean with another sample mean, generally we check the differences in means, whether mean significantly different from one category to other category or not. So who will decide? The p value. P value decide. But when we calculate manually, what do? We use the formula and we obtain the calculated value. Calculated value means we apply the formula and then we calculate through. This is our calculated value, and then another is critical value. Critical value. Critical value may be 3.8 for the 5% significant level of 7 degree of freedom. 7 degree of freedom. So we check what is the critical value and then we compare. If calculated value, if this value is greater than the critical value, then we assume there is a significant difference. But in a SPSS, we do not need to do anything. Only p value will tell us whether this difference is significant or not. Second test, that is independent t-test. What is independent t-test? In an independent t-test, basically this test is used when there are two mutually exclusive groups or two experimental conditions and different participants were assigned to each conditions. So in a independent t-test, basically we divide sample into two mutually exclusive category, like male, female, rural, urban, Lucknow, Varanasi. Is it clear? So when we compare the perception level of male students and female students, then we use independent t-test. So we divide sample into two mutually exclusive groups. In this workshop, male participants and female participants, both participants are participating in a 1 week workshop. If I conduct tests in 100 marks, MCQ, so whether male students serious or female, so I will check through the tests. So I will develop, first of all, I will develop the hypothesis if there is no significant difference performance of male participants and female. This is my null hypothesis. And alternate hypothesis, there is a significant difference performance of male students with female students. So when we compare, if my study comparative study, then I will use the independent t-test. Now you can see the case study. So what is the condition? Conditions of the independent t-test is one independent variable with two levels, means mutually exclusive category, two levels, nominal scale question. So there are two variable, one dependent variable, another independent variable. Independent variable influence the dependent variable. Dependent variable should be continuous and independent variable should be nominal or categorical, and observation should be independent. Now you can see how to prepare your question for one sample t-test. We should prepare one questions in a metric data. The question should be either interval scale or ratio scale. And another question, my independent variable should be categorical. So here my one variable independent, that is gender, nominal scale question, and the salary, that is continuous metric data. So when we want to compare two categories, two levels, two groups, two cities, then we should keep in mind, we should prepare two questions. One question should be nominal and another question should be the continuous scale. Is it clear? Now the case study. The example to know whether the salary of male faculty members in private institutions is equal to salary of female faculty members. Researcher collected data from 20 male. Researcher wants to know whether is it any gender discrimination or not in a private sector. Gender discrimination. So researcher collected 20 male faculty members salary and 20 females. So here there are two variable, X, that is independent variable, Y, dependent variable, X, non-metric categorical variable, male teachers, female teachers, and salary, continuous variable, metric data. So there are two variables, one dependent variable and another independent variable. So independent variable should be categorical. So my question should be look like this: the salary dependent variable and gender independent variable. So before test we will frame the hypothesis, null hypothesis and alternate hypothesis. Null hypothesis means there is no significant difference between getting salary by male, means mean salary of male teachers equal to the mean salary of female teachers. We always assume in a null hypothesis there is no significant relationship, there is no significant impact, both the groups are same. So there is no significant difference between getting salary by male and female teachers in private sector or private institutions. Alternate hypothesis means no, there is a significant difference between getting salary by male and female teachers in private sector. What will I do? I collected data of 20 female teachers, 20 male teachers, and then I will take mean value of female teachers, mean value of the male teachers, then I will compare whether the mean value, mean value same or not. Is it clear? So my data set, I'm opening the data. So here I took 20 male teachers. I coded 1 for male teachers and 20 female teachers. 20 female teachers. 20 female teachers and 20 male teachers. First male teacher salary was 45,000, another 46, 54, and female teacher salary 38,000, 29, 29. So we have 40 observations. What will we do in a independent t-test? Basically, we will compare the mean salary of male teachers with mean salary of female teachers. We are comparing two means. So it is parametric test. So before applying parametric test, we should check whether data normally distributed or not, whether data homogeneous or not. So how to check the normality and homogeneity of the data? Analyze descriptive statistics, explore. I'm checking assumptions. Analyze descriptive statistics, explore. Then what is your gender? I'm transferring into the factor list box and my continuous variable into the dependent list. Is it clear? So always we will transfer categorical variable in factor and continuous variable in dependent list. I'm taking the option of plots. I'm pressing this plots. I'm picking normality, case test, and leave-in test for homogeneity. So there are, for normality, I will obtain the value of case test. For untransformed, I will obtain the value of leave-in test. Is it clear? Here leave-in test. And then continue. After continue, we will check whether p-value greater than 0.05 or less than 0.05. The test of normality. So the case test value for male teachers, the p-value 0.200, and for female teachers p-value again 0.200, means p-value greater than 0.05. It means data normal. Now we check the homogeneity of the data. For homogeneity, salary of teachers, you can take the value of this 0.435, p-value 0.435, test of homogeneity of variance, again p-value greater than 0.05. It means my data homogeneous and as well as normal. So there is no issue of assumptions of independent t-test. Now I can apply independent t-test. So I'm applying now independent t-test. I'm comparing the mean value of male teachers with mean value of female teachers. Okay. So how to apply the independent t-test? Analyze, compare means, and independent sample t-test. Analyze, compare means independent sample t-tests. Then what is your gender? I will transfer into the grouping variables. Is it clear? Now you can see the define groups. Define groups. I'm pressing this. So I coded one for male teachers and two for female. Is it clear? And then continue. After continue, salary of teachers, I'm transferring into the test variable box. And then, okay, press this button, okay. And after okay, we will get the results. Now you can see the results. In this result, we can see the Y and X. Male teachers salary mean how much? 49,900. And female teacher salary mean 39,400. How much difference? Difference is 10,500. Whether this difference significant or not, who will tell us? P value. If P value less than 0.05, it means this is a significant difference, and we conclude there is gender discrimination in private institutions. Males are getting higher salary than female teachers. So there are three groups you can see. The salary of the one group, male teachers, 50,000, 50,000, and male and female 49,000. So there is a difference, 50,000 and 45,000. Again, this is difference. And third is 50,000 and 40,000. Which one is significant difference? I think this is not a significant difference. Only 1,000. It's not a, you cannot generalize, there is a discrimination. But if you see the difference is 10,000 or more, so this is a big difference. So this t test value t equal to 4.088 and the p value less than 0.05, it is 0. It means the p value less than 0.05 means there is a significant difference. Now you can conclude that there is a gender discrimination in a private sector. Otherwise, we will, if p value greater than the 0.05, it means there is not significant difference. Now you can interpret this result. How to interpret and how to write, how to report the independent t-test in the research paper or thesis. From the output, t value was 4.068, that the number of degree of freedom on which this was 38 and that it was significant at p less than 0.05. The mean value for each group, average male teachers obtained higher salary than 2 female teachers. This difference was significant. So you will interpret T within bracket degree of freedom equal to value, calculated value, that is 4.068, and P value less than 20. Third case, that is paired T test. So we apply one sample T test where we analyze only one variable. Independent T test, the situation of independent T test or applications when we compare two groups, mutually exclusive group. And third test, that is paired T test. Paired T test tell us whether the experiment is whether the experiment successful or not. So you can take example of the paired T test. So there are 10 participants. They want to reduce their weight 1, 2, 3, 4, 10. The baseline weight is 90 kg, 95 kg, and so on. The yoga teacher told to 10 participants, through yoga, you can reduce your weight. And the time period is 3 months. If you do continuously yoga 3 months, then your weight will be reduced. So this is experiment. Experiment is yoga. Another experiment, another manipulation may be the training. Is it clear? So after 3 months, the weight of the first participants 75 kg, 70 kg, 65 kg, and 58 kg. So whether this difference is significant or not, we will check through the paired T test. Is it clear? So paired T test, basically, we use paired T test where we want to know the impact of one variable on the other. Means there is the experiment may be yoga, experiment may be diet, experiment may be the other technique medicines. Is it clear? So we want to check whether the yoga effective for reducing the weight or not. So we will check it through the paired T test. The limitation of paired T test, only we can check before test and after test. We can take only the same respondents. We can observe 2 times same respondents. But if we want to take more than 2 observations, then we will use repeated measures ANOVA. For example, you want to measure the performance after 1 month, after 2 months, after 3 months. Is it clear? So, and this is baseline weight, baseline weight. So if you are taking more than 2, if you are taking observations, same respondents observations more than 2 times, so we use repeated measures, and over here we will not use paired T test, because in a paired T test we can compare only 2 groups. 2 means before test and after test, and the duration may be 1 month, 1 year, 3 months, 6 months. So you can check it. Is it clear? Now the condition of in a before and after, you can the pre-measure, manipulation, and post-measure. The paired sample T test compare 2 means that are from the same individuals. Here we should keep in mind, in an independent T test, we divide our population into 2 groups, male, female, rural, urban. We compare. But in a pair t-test, we observe 2 times same respondents. A measurement taken at different times, pre-test and post-test. Generally, this type of test used in medical sciences. They want to uh, check whether the particular dose effective for patient or not. So before and after, they compare the results. Here, the data should be continuous and pre-test and post-test observations of same objects. The case study. In this case study, the university arranged a special faculty development program for one segment of its teachers. The university wants to measure the change in the attitude of teachers after the faculty development program. University thinks if we send our employee to other organization for a training, whether the attitude change or not. So for this purpose, they use the questionnaire, and then university selected the 20 teachers for a faculty development program. So we will take observations before joining the faculty development program, the attitude score, and after the faculty development program, again, we will take the uh, responses of 20 teachers. So dependent variable to test whether measured at 2 different times for 2 related conditions or units. Before training, the teacher's attitude score is 25, and after joining the faculty development program, the score increased from 25 to 38. Second person 35 to 48, 45, 24 to 40. Now we want to check whether this difference 32 minus 25, whether this difference significant or not. If this difference significant, we will generalize the training program, motivate teachers, and training program change the attitude of the teachers. So we will develop the hypothesis. First of all, in a null hypothesis, we always assume there is no significant impact of training program on teachers attitude. कितने भी करा लो वर्कशॉप ट्रेनिंग, कोई चेंज नहीं होने वाला. But alternate hypothesis says there is a significant impact of training program on teachers attitude. Is it clear? Now I am opening the data set to check whether the difference is significant or not. So there are observations before the training program, 20 participants score, and then we will take after the training program score of 20 employees, and then the third column, that is the difference, 35, 10, 8, 13. So before applying the pair t-test, we will check assumption of pair t-test. And what is the assumption? The assumption is data should be normally distributed. Here we will not check homogeneity because only one group. So how to check the normality? Go to analyze, descriptive statistics, and explore. Is it clear? Analyze, descriptive statistics, explore. Then what should we do? We will transfer difference. We will not individually check normality of the before and after variable. We will check normality of the difference between the two. That is this. And then plots. Press this button, plots. When I press this button, plots, then you can see, you can tick normality plots with test. And then continue. And after continue, press this button, OK. Then we will get KS test P value, and P value should be greater than 0.05. If P value not greater than 0.05, then we will not apply pair T test. We will apply then non-parametric test, which is the Wilcox-Conrang sign test equivalent to the parametric test. So first of all, we will check the normality. What is the P value? Here P value again greater than the 0.05. P value equal to 0.2. It means greater than 0.05. Means non-significant. It means data normally distributed. There is no problem. We can directly apply the pair T test now. So I am opening the data set. Analyze. Compare means paired sample T test. Analyze. Compare means paired samples T test. Then transfer before faculty development program and after faculty development program. अब इसका यूज नहीं है. There is no use of difference. We use difference only for normality checking purpose. And then continue. After continue, we can check our results. Yes, you can see. Before faculty development program, the mean score of 20 teachers was 24.75. And after the faculty development program, so before the faculty development program 75, and after the faculty development program 33. And there is a difference of 9.5. Whether this difference is significant or not, who will tell? P value. Whether our null hypothesis will accept or reject, who will tell this P value? And what is the P value? Last three column. And P value less than 0.05. It means this difference, not a small difference, it's a big difference. Now we can conclude, generalize कि faculty development program or training program in an organization improve the performance of the employees. Now question is how to write in a research paper. From the output, the T value was minus 7.963. That the number of degree of freedom on which this was 19 and that it was significant at p-value less than 0.05. The mean value for each group, on average, teachers' attitude were lower before training program to after training program, and this difference was significant. Okay. Now I take the fourth case study, that is related to analysis of variance. In an analysis of variance, basically it is the extension of independent t-test. In an independent t-test, we compare two groups. But if we want to compare more than two categories, like high, medium, and low, there are three categories, then we will apply analysis of variance, or we can say it's a extension of the independent t-test. What is the ANOVA? This test useful to analyze situation in which we want to compare more than two conditions. If I am comparing performance of students Delhi, Mumbai, Kolkata, I'm taking three states, three metro cities. So when I compare more than two categories, then I will apply the analysis of variance. Same as doctors again can give the medicine in three conditions. They are giving 2.5 ml dose to some patients, means 5 patients, 5 ml dose to 5 patients, and 7.5 ml dose to the uh, uh, the the 5 patients, and they want to know whether the dose improve the health of the patients or not. It means when we increase the dose, if 5 ml dose improve the health of the patient, it means there is no need to give overdose to the patient. If we are getting good result from the 2.5 ml dose or 5 ml dose, then there is no need. So in a analysis of variance, there are two variable, one independent variable, more than two levels, and one dependent variables. This independent variable and dependent variable. So through yoga, there is the results of 1 month, results of 2 months training period of yoga, and 3 months. Is it clear? 5 patients, you can compare the performance of the one level to the another levels. Is it clear? So you can apply the one independent analysis of variance. The situation you can see here, in this case study, an experiment in which a major department store like Domino, domino pizza. Okay. Wanted to examine the effect of level of in-store promotion. The experimenter wants to know the impact of store promotion on sales. In a particular cities, there are 5 outlets of Domino Pizza. If I divided a city into 3 geographical areas, there are 5 outlets here, 5 outlets in this region, and 5 outlets. The first, second, third. In the first area, in this area, region, we are not giving any discount. No discount, no promotion. The second, medium promotion, we are giving 10% discount in a 5 outlets. And another group, we are giving 40% discount. Is it clear? So we want to check whether 10% or 40% discount increases the sales or not. So we will check it through the analysis of variance. So this is very simple case study. The no promotion, medium promotion, and high promotion. So we will develop the hypothesis. The hypothesis is null hypothesis. The mean outcome is the same across all categories in the all the 3 regions. The mean salary, sorry, the mean sales same. Okay, there is no impact of 10% discount and 40% discount. But alternate hypothesis is no, at least one pair different from the other pair. If the sale of one region does not equal to the sale of another region x2 or x3, it means there is a significant difference. So how to perform it? I am just opening the data set.
Excuse me, sir.
Yes, put your question.
Sir, so the difference between the independent t-test and this test is
Huh.
because of the number of groups.
Yes. In the limitation of independent t-test, we can compare only 2 levels, male, female. Is it clear? If we want to compare more than 2 levels, then we will use the in analysis of variance ANOVA. For example, you are conducting a training program and there are 2 groups. One is control group and another is experimental group. Is it clear? So you want to check whether the changes in the experimental group happened or not. Is it clear? But if you take 3 groups, one control group where you are not manipulating any variable, and the 2 other groups where you are giving low changes and another group high changes. Is it clear? So when you compare more than 2 groups, 2 levels, 2 categories, more than 2 categories, more than 2 levels, then use analysis of variance. Is it clear?
Yes, sir. Yes.
Okay.
Thank you.
Any question? अभी किसी का कोई क्वेश्चन है? Otherwise, चलिए at the
Sir,
end of this. Yes.
Sir, in hypothesis that you are always making the null hypothesis as well as the alternative hypothesis. So,
Yeah.
is it necessary to construct the 2 types of hypotheses for all the researchers?
Yes, 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 yes. Whether your research is in medical science, in a psychology, in a management, commerce, economics, everywhere there are two types of hypothesis: null hypothesis and alternate hypothesis. So, null hypothesis, we always assume that there is no significant difference, there is no significant impact, there is no significant relationship. Writing, so there may be criteria to writing the hypothesis. The one is there is a the null hypothesis is there is no significant impact of one variable to another variable. Yeah, there is no significant relationship between the two variables. Yeah, there is no significant impact. Is it clear? So in a null hypothesis, we always assume there is no significant difference, and alternate hypothesis means there is a significant difference. So when we conduct our hypothesis, so we always assume there should be some significant results. If you are conducting experiment, then then your result should be different from the control group. Is it clear?
Yes, sir.
Okay. Now the analysis of
Yeah. So,
variance.
sir, we have to construct the when we perform our research, then we have to construct the two types of hypothesis: one null hypothesis as well as the alternative hypothesis, right,
Yes,
sir?
yes, yes. Yes, sir. Yes, sir. Yes. Absolutely right.
Okay, sir. Yes, sir. Okay, sir. Okay.
Now the case study, there are 5 outlets where we are not giving any discount, no promotion. No promotion. You can see. And the mean sales of the 5 outlets, when we combine the all observation and divide by the 5, we will get the mean sale. And where we are giving 10% discount, the sale increase slightly. And when we give 40% discount, there is a much difference, you can see. Okay. So directly I am performing the analysis of variance. I'm not checking the assumptions now. You can check assumptions. I'm directly performing the analysis of variance. Go to analyze, compare means, and one way ANOVA. Is it clear? Analyze, compare means, and one way ANOVA. Is it clear? Now we will transfer categorical variable sales promotion into factor and sales in dependent lists. Is it clear? Sales and then post hoc analysis. Press this button, Bonferroni. There are 18 tests. So what is the purpose of Bonferroni test? I'll explain later on. Then continue. After continue, options, press this button, options, tick descriptive, and then continue. After continue, press this button, OK. Now you will get the output. So in this output, you can see there are 3 categories. When you are not giving any discount, the mean salary is 22 lakhs. When you are giving 10% discount, the mean sales increase 32 lakhs. When you give 40% discount, the mean sales 50 lakhs. Is it equal or not equal? Are all the values are equal or not?
Not, sir.
Not equal. Yes, you are right. Because all the values are different. But whether this difference significant or not, who will tell? P value. And here P value is saying in ANOVA table, P value less than 0.05. It means this difference is significant. And we can conclude sales promotion or discount increases the sales. Now, what is the purpose? Whether the 10% discount increase significantly or 30%, we do not know. For that purpose, we use post hoc analysis. So we will compare, we will create two pair, 22, 30 and 50. There is one pair and another pair, this. Whether the no promotion with medium promotion significant or not. So when we compare the 22 lakhs with 30, so this is not significant. Then no promotion with high promotion. Whether this difference significant or not, yes. If you give 30% discount, dramatically sale will increase. Is it clear? So here, so the purpose of post hoc test is to compare the pairs. Is it clear? Now we can conclude that the sales promotion technique increases the sales, and then we can write the results. These are our hypotheses.
Excuse me, sir.
हाँ शिवानी बोलो.
Yes, sir. अभी जो आपने अभी जो समझाया ना सर, ये जो नो प्रमोशन और मिडिल प्रमोशन के बीच में जो डिफरेंस था सर, वो समझ नहीं आया था सर.
कोई बात नहीं, मैं फिर से समझा देता हूँ. So basically here we are creating two pairs, Y and X. The mean salary of no promotion, 22 lakhs, and the mean salary of the medium promotion, 30 lakhs. This is one pair. Is it clear? And second pair, 22 lakhs, no promotion with high promotion. Is it clear? So this one, another pair. So whether if I increase 10% discount, naturally sale will increase. But this difference is not significant. Why? Because P value greater than 0.05. But when I compare this difference, here the difference is 8 lakhs. So this is not significant. But when I compare other pair, 20 lakhs with 50, how much difference? 20 lakh. It's a very, the sale just double, more than double. So this is significant. So how will check no promotion with high promotion? The P value is less than 0.05. शिवानी समझ में आ गया?
सर ये जो पहला वाला कॉलम है इसमें मीडियम प्रमोशन एंड हाई प्रमोशन जो दिया हुआ है।
हाँ हाँ, इसका कंपेयर
सर
किया है इसने, बेसिकली पेयर बनाया, पेयर।
हाँ, मीडियम और हाई को कंपेयर किया है तो सर
हाँ
सिग्निफिकेंट 0.845 है।
हाँ, मीन्स पी वैल्यू ग्रेटर देन 0.05।
ओके सर
सिग्निफिकेंट डिफरेंस हम तब कहेंगे व्हेन पी वैल्यू लेस देन 0.05।
सर ये जो दो सिग्निफिकेंट वैल्यूज दिए ना, ये
दो कहाँ दिए?
0.8,
एक तो
एक
पॉइंट
पॉइंट,
845 है, ये तो सिग्निफिकेंट नहीं आ रही है
यस सर।
क्योंकि पी वैल्यू 0.05 से ग्रेटर है।
हाँ हाँ
सेकंड जो आ रही है बेटा, बोलो 0.025 लेस देन आ रही है 0.05 से, है ना?
यस सर।
तो मतलब टू पेयर
सर
बनाए कि यस।
सर आई थिंक वो पूछना चाह रही कि जो हम ये जो दो वैल्यूज हैं पी वैल्यू की, तो वो एक नो प्रमोशन विद मीडियम प्रमोशन है और फिर एक
हाँ
नो प्रमोशन विद हाई प्रमोशन है।
हाँ हाँ हाँ,
आई
बिल्कुल
थिंक वो
बिल्कुल
नहीं
वैसे
पता
ही है।
होगा। जी।
ओके ओके ओके।
शिवानी समझ में आ गया प्रखर ने
हाँ
जो
जी
बोला?
हाँ जी हाँ जी
हाँ,
यस।
दो वैल्यू है ये, देखिए। एक तो मैंने एरो भी बना दिया ना। एक तो पेयर हो गया नो प्रमोशन विद मीडियम प्रमोशन, इसमें पी
ओके।
वैल्यू ग्रेटर देन 0.05।
हाँ
सेकंड
जी।
पेयर बनाया मैंने नो प्रमोशन विद हाई प्रमोशन, एरो करके, वो
यस सर।
सिग्निफिकेंट आ रही है।
ओके ओके
ठीक
सर।
है, ओके।
यस यस थैंक
तो
यू।
फिर सर मीडियम प्रमोशन और हाई प्रमोशन के बीच का डिफरेंस हम नहीं निकलेंगे
नहीं नहीं,
कैसा?
उसकी जरूरत नहीं है एक्चुअली, वी विल कंपेयर विद बेस लाइन। वो पेयर
ओके
बन
ओके
सकता है, you can create third pair, but there is no need. You should compare with base value or control group.
ओके ओके सर।
ठीक है। Now the how to write the results of independent t-test. So a one way between subject and ANOVA was conducted to compare the impact of promotion levels of sales. There was a significant effect of amount of promotion on sales at p less than 0.05 for the three conditions. ठीक है, यहां पर देखिए, when Bonferroni was conducted, then there is no significant difference, no promotion with the medium promotion, but high promotion significantly different from the no promotion. These results suggest that high levels of performance promotions really do have an impact on sales. Is it clear? Now, my last case study, that is today's lecture, last case study, repeated measures and all. In this case study, the dietitian introduces new diet chart plan to reduce weight loss. The dietitian took 15 women who considered themselves to be in need of losing weight and put them on this diet for 3 months. Their weight was measured in kilogram at the start or baseline of the diet, and then measured after 1 month, after 2 months, after 3 months for checking the impact of diet plan. So the hypothesis is there is no significant impact of diet on weight loss. But alternate hypothesis is no, there is a significant impact of diet on weight loss. So how to perform it? This is my data set. Total participants 15 women. First women weight 105 kg. After joining the training program, weight reduced 98. After 2 months, weight 92, and after 3 months, 75. For second participants, again you can see the weight is reducing. So when we compare more than two same group, then we use repeated measures ANOVA. So here you can see these are our data set of baseline weight after 1 month. Through data we can say weight is reducing. So can we say this training program is meaningful or not? So p value will tell us whether this training program really reducing the weight or not. Is it clear? So from the data you can say this training program is good. After 3 months, the weight is very less in comparison to baseline. So I'm performing repeated measures now. It's an extension of a paired t-test. In a paired t-test, we can check baseline weight with after 1 month. Okay. So it's an extension of paired t-test. Now the linear repeated analyze general linear model repeated measures. Is it clear? Now you can write the name. I'm giving the name of my factor, that is weight. How many level? There are 4 level. Baseline weight after 1 month, after 2 months, after 3 months. So there are 4 levels. Then press this button. After that, define. After defining, select all the 4 variables and transfer into the within subject variables. Within subject variables. Is it clear? Now press this button model. Nothing to do. Continue. Then contrast. Change polynomial with repeated. And then press this button change. After change, continue. In a plots, nothing to do. Continue. Post hoc, nothing to do. Then options. Options. Transfer both the variable overall and weight. Tick this option, compare main effect. Select SIDAC. Then tick this button under the display descriptive statistics. Estimates of the effect size. Transformation matrix. And then continue. And after continue, okay. Now we can see our results. Now in the first table, you can see descriptive statistics. The mean weight of 15 women, baseline weight, mean weight was 102 kg. After 1 month, 93.87 kg. After 2 months, 85.07 kg. After 3 months, 69.8 kg. Whether this difference significant or not, this p value will tell us. Pillai trace, Wilks lambda, Hotling trace, Roy largest root. All the p values less than 0.05. It means the training program is working. The training program significantly reducing the weight of the participants. So this is about the small idea of the tests. Now you are most welcome. If you have any query, you can unmute yourself and you can ask questions.
So this
So
repeated ANOVA, what you have said, that is it called the two-way ANOVA, or is it the one-way
No, no, no,
ANOVA?
no. Two-way ANOVA is different from the two-way ANOVA, different from the repeated measures ANOVA. Basically, I'm giving the example of two-way ANOVA. एक मिनट रुकिए. Yes. Okay. In ANOVA, basically the ANOVA, one-way ANOVA. One-way ANOVA, y equal to x1, and x1 your independent variable, y dependent. This is metric, this is non-metric. There are three variables. This is one way now. But when you include the other independent variable, there are two categories. Again, it is non-metric, two categories. So it is known as two-way ANOVA. Here we are adding two categories, one x1 independent variable and another x2. So it is two-way ANOVA or factorial ANOVA. It is known as factorial ANOVA. And one is ANCOVA. ANCOVA, analysis of covariance. Analysis of covariance. So what is the condition of there are two independent variables? One should be categorical, non-metric, and another should be metric. Is it clear? It is continuous data. So that is why this is also continuous. That is why this technique known as ANCOVA. And what is MANOVA? Where more than in an ANOVA, more than one dependent variable and one independent variable. An independent variable, again, it is categorical. Both the variables, the continuous variable. So I'm showing you the one picture how to decide whether MANOVA, ANOVA. There is one very good book that the name of the book is Andy Field. So I'm showing you the book. So just wait. The book name, that is Andy Field. I prepared all these slides with this Andy Field book. I think this is the best book to learn SPSS and the statistics, both you can learn. So here the last page, this is the diagram. So the number of dependent and independent variable decide whether we use the one way. No, yes, you can see. For independent t-test, there are two variable, categorical variable, two categorical variable. If data normally assumption, data normally distributed, then we use independent t-test. If my data not normally distributed, I will apply Mann-Whitney U test. So these are the tests one way repeated measures ANOVA, Friedman ANOVA, independent factorial ANOVA, multiple regression, factorial repeated measures ANOVA. So in this book, all these tests explained very beautifully with example. So you can go through this book. It is very nice book. Any question?
Uh,
Other question?
uh, Sir, pardon me for asking a very naive and basic question. When we say something is statistically significant, if the p-value is less than 0.04 or 5%, so what is the theoretical background behind it? What we are rejecting the null hypothesis? Are we saying that the value that we have got is having a chance less than 0.5% being wrong or right? What is the basic intuition behind this 0.05% significance?
Actually, there are three. You can test your hypothesis either 1% significance level and one significant 5% and 10%. Is it clear? 1%, 1%, 5%, and 10%.
Yes.
5% means we are assuming that if we are taking 100 samples, if you're taking 100 samples from this population, then 95% sample mean lie between this range, the 2.5, about 2.5% and below the 2.5% here. Right till at 95% chance that our results are correct. Only 5% may be error. That is why we select the 5% significant level. Only 5 times maybe the sample mean outside this range or outside this upper limit. That is 97.5.
Excuse me, sir.
Yes.
Can I explain his question in an easier manner so that he can understand?
Yeah, sure.
As a student myself, so I can explain it to him better. So,
Yes.
my friend who asked the question, let's say we are calculating something, so we want it to be correct 100% of the time, right? Then we can say for sure that this is the way it is. But in real life, 100% of the time does not happen. So when we say at 99% of the time, if something is happening, then we can be very, very sure, almost completely sure that our result is correct. If it is 95% of the time it is happening, then we can not be 99% of the time correct, but 95% is still a very significant number. And the last is 90%. So 90% of the time our results are correct. So we can, whatever we are trying to prove, 90% of the time that is correct, or 95% of the time it is correct, or 99% of the time it is correct. If it is correct 99% of the time, then it's perfect. It's the best we can hope for. And the least we can hope for is 90%. If it is any less than that, then we cannot say with any degree of certainty that our results are correct. So that is the reason we use these p-values.
Thank you. Very nice.
Did I make myself clear?
I'm asking this question basically.
Think of it in terms of probability. 90% of the time, whatever you are doing is correct. That is what the significance level means.
Thank you for explaining, but actually I was talking about the theory which discards the significance value itself.
So you can go through this statistics book, sir.
Yeah. Well, my only question is that, for example,
sir, we will share this book. So you go through this book. Yes, or any other statistics book you can find it. Why do we take 5%, 1%, and 90? percent?
No, no, no. I'm not asking 1%, 5%. What's the theoretical
Theoretical.
intuition
Theoretically, you
behind that?
can
What is the proof behind that?
yes,
If I
yes,
take 1%, so what we are rejecting null hypothesis or we are approving the null? That's the question.
You're
sir,
proving the hypothesis. That's precisely what I was trying to explain the theory behind it. If whatever your result is, if it is correct 99% of the time, then you can accept it, right? Yes or no?
So
If
when we say I have some impact analysis, I
yeah,
am getting the value less than
yes,
0.05%.
okay,
So whether this 0.05% it should reject or accept
it
depending
is
upon.
alternate hypothesis accept. Your result is
accept. It
right.
is
No,
accepted.
that's the question. What is the theoretical background behind it? Why it
I
is
just
not less than
explained to you the theoretical background
0.0001%?
behind it. It's the probability.
So we will share book for this. Theoretical background के लिए हम एक book
Think
कोई
of
share
it in
कर दें.
terms of probability, my
Okay,
friend.
thank you. I don't want to hold the class. Sorry if I'm interrupting.
Yeah.
No problem, no.
Yes,
Yes, any questions, sir?
Yes, sir. Yes, sir.
हाँ,
सर
शिवानी बोलो.
सर आई वाज आस्किंग कि मेरी जो स्टडी है उसमें मैंने फॉलो अप भी दिया है 3 मंथ्स का इंटरवेंशन है और 3 मंथ्स का फॉलो अप है तो जो मेरी स्टडी है इसमें रिपीटेड मेजर्स ऑफ एनोवा लगेगा
No, if you are taking two observations, आज आप एक observation ले रहे हैं and after 3 months you are taking another observation, then you apply pair t-test. But if you are taking more than two observations, baseline weight after 1 month, after 2 months, after 3 months, then you apply repeated measures ANOVA.
ओके एंड
शिवानी,
इफ आई यस सर
देखो मेरा सवाल ये है, मान लीजिए 3 months का पीरियड है, ठीक है,
यस
you are checking after 1 month, you are taking after 2 months and 3 months,
ओके सर
then you use repeated measures ANOVA. But if you are taking 2 times observations before the program जो आप implement कर रहे हैं and after 3 months, then use a pair t-test before test and after test. Time period may be 3 months, 6 months, but if you are taking more than 2 times observations, then repeated measures ANOVA करेंगे. ठीक है ना?
yes sir yes sir so in my case I am taking follow up also so it is observation is being done for 3 times
Then you use repeated measures ANOVA.
without giving any intervention I am just giving the taking the
हाँ हाँ,
result.
कोई दिक्कत नहीं है.
Okay, sir.
हाँ,
सर
yes, yes.
सर जब हम कुछ ऑनलाइन सॉफ्टवेयर के थ्रू जब हम टी टेस्ट लगाते हैं तो उसमें कुछ थोड़े कन्फ्यूजन आते हैं सर जैसे अगर हम ग्राफ पैड का यूज करते हैं तो वहां पर वो पूछता है कि पेयर्ड टेस्ट लगाना है या अनपेयर्ड या डिपेंडेंट या इंडिपेंडेंट और वन टेल टू टेल या बिटवीन ग्रुप एनालिसिस और विद इन ग्रुप एनालिसिस तो ये सर थोड़ी सी टर्म्स अगर आप क्लियर कर सकें
देखिए, one tail and two tail means when you are sure that result will be in this direction, then use one tail test. Is it clear? When you do not know whether the outcome in a lower tail side or upper tail, then use, when you do not sure whether the outcome will be in a lower side or upper side, then use two tail. Is it clear? But in a SPSS software, there is no concept of one tail. Is it clear? Now, second is your question is the paired t-test or unpaired. Paired means when you are taking same respondents observation before treatment and after treatment. Paired, unpaired means it is independent t-test. Independent t-test, also known as unrelated test, unpaired test, and paired t-test, also known as dependent test and the related test. Between groups and जो पूछा था आपने वो we will use the between group and among the group. So between group and among the group we will use in analysis of variance. Is it clear? और ये जो बुक है एंडी फील्ड का, इसमें बहुत क्लियरली डिफाइन किया है इन्होंने जो आपके सवाल हैं। डिटेल के लिए आप उस बुक को पढ़ सकते हैं, ठीक है।
जी सर, इसमें सर जैसे आपने पेयर टी टेस्ट में जो आपने एग्जांपल लिया था योग वाला,
हाँ
इसमें एक ग्रुप था, उसका बिफोर एंड आफ्टर लिया गया कि उसने एक योग इंटरवेंशन करा, और
बिल्कुल।
बिफोर आफ्टर हमने डेटा ले ली। तो अगर उसमें सर हम एक ग्रुप और ऐड कर दें, कंट्रोल ग्रुप, जिसको हम कुछ ना कराएं, तो इस केस में फिर हम सर किस तरीके का टेस्ट लगाएंगे?
इसमें जो है आप इसको कंपेयर करने के लिए एनकोवा भी लगा सकते हो उसमें। उसमें जो है ना, आप दो ग्रुप बना सकते हो। कंट्रोल ग्रुप के लिए आप कर लेंगे एक्सपेरिमेंट, इज इट क्लियर? और सेकंड ग्रुप में एक्सपेरिमेंट आप कर रहे हैं। बात समझ में आ रहा ना? दो
जी
ग्रुप
जी
आपने बनाए, एक तो एक कंट्रोल ग्रुप एंड अनदर एक्सपेरिमेंटल ग्रुप। तो इफ यू आर
जी
कंपेयरिंग experimental group with control group, then you can apply independent t-test। बात समझ में आ रहा है ना भाई? एक आप कंट्रोल ग्रुप से कंपेयर कर रहे हैं, या सेपरेटली यू कैन कंडक्ट टू पेयर टी टेस्ट। इज इट क्लियर? इन ए
जी
वन ग्रुप बिफोर टेस्टिंग एंड आफ्टर द पर्टिकुलर टाइम पीरियड, कंट्रोल ग्रुप को आप मेजर कर रहे हैं। एंड देन द पेयर टी टेस्ट बिफोर टेस्ट एंड आफ्टर इंटरवेंशन you can take observation, and then you can compare the results of control group and experimental group. If you are comparing the two group, then again you can apply independent t test। एक ही उसमें नहीं होगा, उसमें एक ही टेस्ट से।
तो मतलब फिर हम जो हमारे दो ग्रुप्स हैं उसका हम पोस्ट डेटा का इंडिपेंडेंट टी टेस्ट कर लें,
हाँ
कि
हाँ,
आफ्टर
कंट्रोल
आफ्टर द
कंट्रोल।
इंटरवेंशन जो एक्सपेरिमेंटल ग्रुप था और
हाँ,
जो कंट्रोल ग्रुप उसका
यस
हमने
यस
कर
यस,
लिया।
बिल्कुल बिल्कुल बिल्कुल। ये जो है एक्सपेरिमेंटल ग्रुप और कंट्रोल ग्रुप के लिए भी होता है कंपेयर करने के लिए इंडिपेंडेंट टी टेस्ट, कि
तो
सिग्निफिकेंट
इंडिपेंडेंट
डिफरेंस
में
आ
भी
रहे हैं कि
सर
नहीं आ रहे
पेड
हैं।
और अनपेड होते हैं?
मान लीजिए कंट्रोल ग्रुप में मीन वेट आ रहा है आपका 70 kg, एंड एक्सपेरिमेंटल ग्रुप में मीन वेट आ रहा है, एक्सपेरिमेंटल ग्रुप का मीन वेट आया आपका 80 kg, वो 60 kg।
जी।
तो यू कैन कंपेयर कंट्रोल ग्रुप विद एक्सपेरिमेंटल ग्रुप थ्रू इंडिपेंडेंट टी टेस्ट।
ओके। तो
ठीक है।
इंडिपेंडेंट टी टेस्ट में सर पेड और अनपेड का नहीं होता, वो केवल
ना ना ना
इंडिपेंडेंट?
ना भाई, पेयर्ड टी टेस्ट ऑल्सो नोन एज डिपेंडेंट टी टेस्ट। अनपेयर्ड टेस्ट मींस इंडिपेंडेंट टी टेस्ट, अनरिलेटेड टी टेस्ट। इसके तीन नाम है। देखो, डिपेंडेंट टी टेस्ट, इंडिपेंडेंट टी टेस्ट, पेयर टी टेस्ट, अनपेयर टी टेस्ट, रिलेटेड सैंपल, अनरिलेटेड सैंपल। अनरिलेटेड मींस इंडिपेंडेंट टी टेस्ट, रिलेटेड मींस डिपेंडेंट। बात समझ में आ गई ना? इसमें कंफ्यूजन कुछ नहीं होना है। आप चाहें तो लिख लें, रिलेटेड टेस्ट, डिपेंडेंट टेस्ट, पेयर टेस्ट सेम, अनरिलेटेड टेस्ट, इंडिपेंडेंट टेस्ट, अनपेयर टेस्ट सेम।
जी, तो हम जो पे जिसमें हम पेड में हम जो पेयर बनाते हैं वो सेम ही ग्रुप की दो वैल्यूज
हाँ
का बनाते हैं?
हाँ हाँ, सेम ग्रुप की।
जी
कंडीशन ये है, अगर म्यूचुअली एक्सक्लूसिव डिवाइड कर रहे हैं कंट्रोल ग्रुप विद एक्सपेरिमेंटल, इट मींस इंडिपेंडेंट टी टेस्ट। और सेम ग्रुप को अगर आप दो बार कर रहे हो, तो उसको हम कहेंगे पेयर टी टेस्ट, और रिलेटेड टी टेस्ट, और डिपेंडेंट टी टेस्ट।
जी।
सेम
सर
लोगों का
बस
जब दो
एक
करो।
क्वेश्चन और था।
बोलो
सर एक क्वेश्चन और पूछ सकता हूँ? जी
बोलो
सर, वो
बोलो।
नॉर्मेलिटी से रिलेटेड था कि जब हमारा सैंपल नॉर्मली डिस्ट्रीब्यूटेड है, तो वो ये डिनोट कर रहा है कि हमारा सैंपल पॉपुलेशन को ट्रूली रिप्रेजेंट कर रहा है।
नहीं नहीं,
लेकिन
वो हमने वहां पे जो लिया ना, सैंपल जो लिया है, हमने ये लिया है
जी
कि सैंपल में होमोजेनिटी, मतलब वो करेक्टरिस्टिक्स हैं पॉपुलेशन की या नहीं। अब वो हमने ले लिया कि जो सैंपल जो हमारा है, वो पॉपुलेशन से जो हमने लिया, कि उसमें कोई डिफरेंस नहीं है। वो डेटा
जी
नॉर्मली डिस्ट्रीब्यूटेड है, रैंडमली आपने लिया है। ऐसा नहीं है कि जैसे मान लीजिए क्लास में 100 स्टूडेंट्स हैं, ठीक है। अब
जी
100 स्टूडेंट्स में मैंने जो मीन वेट ले लिया स्टूडेंट्स का, वो 70 kg है। और मैंने जो उसमें 10 स्टूडेंट्स लिए, सैंपल लिए, ऐसा नहीं होना चाहिए कि 10 के 10 स्टूडेंट्स का वेट बिल्कुल कम वाला हो या हायर साइड का हो। मतलब उसमें रेंडमली, मतलब उसका मीन डिफरेंस, सैंपल का पॉपुलेशन मीन डिफरेंस से अलग नहीं होना चाहिए। ये हम कहते हैं नल हाइपोथेसिस में, कि कोई डिफरेंस नहीं है, पॉपुलेशन मीन की कैरेक्टरिस्टिक सैंपल मीन में है। फिर वो जो सैंपल लिया उसके अंदर हम कंपेयर कर रहे हैं कि इसमें कोई डिफरेंस है इनमें या नहीं। तो नॉर्मेलिटी चेक करने के लिए कि जो सैंपल लिया है पॉपुलेशन से वो उसका रिप्रेजेंटेटिव है, उसमें वो सारी कैरेक्टरिस्टिक्स हैं सैंपल में जो पॉपुलेशन में।
जी जी सर, इसी से रिलेटेड क्वेश्चन था कि अगर हमारे सैंपल नॉर्मली डिस्ट्रीब्यूटेड नहीं है या उसमें हेट्रोजेनिटी है, तो
हाँ,
इसका मतलब कि वो पॉपुलेशन को रिप्रेजेंट नहीं कर पा रहा।
पॉपुलेशन को नहीं कर पा रहा, कहीं सिलेक्शन में, सैंपल सिलेक्शन में आपका गलती हो गया।
जी, तो मतलब सर अगर ऐसा डेटा मैंने ले लिया, अगर मेरे पास
हाँ,
ऐसा ऐसा डेटा आ गया, तो उस डेटा के साथ अपनी स्टडी को कंटिन्यू करना तो फिर सर लॉजिकल नहीं है।
नहीं 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 नहीं, आप कर सकते हो लॉजिकल, उसका भी तरीका है, थ्रू नॉन पैरामेट्रिक टेस्ट। देखो आपने जानबूझ के नहीं किया, वो डेटा में
जी
वो चीजें आ गई, तो इसके लिए भी सॉल्यूशन है। फर्स्ट ऑफ ऑल यू विल करेक्ट योर डेटा, करेक्ट करने के बाद भी नॉर्मल और होमोजीनियस नहीं आ रहा, देन यू गो फॉर द क्या कहते हैं, नॉन पैरामेट्रिक टेस्ट।
जी। तो इससे सर क्वालिटी ऑफ रिसर्च पे कुछ इफेक्ट पड़ेगा सर कि
कुछ नहीं
अगर
फर्क
मैं
पड़ेगा,
सेम
कोई फर्क नहीं पड़ेगा। देखिए सर ने
अगर मैं सेम सेटिंग
नरेंद्र
सेम
जी ने
रिसर्च करूँ।
आर्टिकल ये भेजा है, आर्टिकल,
जी
ये आर्टिकल भेजा है आपने, ये वाला चैट बॉक्स से आप लोग कॉपी करके इसको रख लीजिए, और आप उसमें ग्रुप में भी शेयर कर दीजिए, या मुझे कर दीजिए, आप उनको कर दीजिए, इसको शेयर कर दीजिए तो कर लेंगे हम। एनी क्वेश्चन?
यस सर, सॉरी सर, एक दो क्वेश्चन और है सर। अभी
हाँ
जैसे
पूछो।
इन्होंने कहा सर ने कि जो डेटा है वो नॉर्मल नहीं आ रहा है, तो क्या उसके